There are several concerns with installing 120 volts alternating current duplex receptacles in an application requiring 28 volts direct current radio receptacles in wire mold. Firstly, NEC Section 210.8 addresses receptacles for appliances and states they shall have amperage ratings that are not less than the branch circuit ampere rating. In this situation, the branch circuit is rated for 20 amps, while the receptacles are rated for 15 amps, creating a discrepancy. Secondly, NEC Section 400.23 states that receptacle outlets shall be of the ground fault circuit interrupter type unless specifically exempted. This installation lacks ground fault circuit interrupter protection. Thirdly, NEC Section 620.21b mandates that audio signal circuit shall be separated from other circuits. The alternating current and direct current circuits are sharing the same wire mold, which violates the separation requirement. In addition to code violations, there are other crucial concerns. Plugging a 120 volts appliance into a 28 volts direct current receptacle could cause damage to the appliance and potential shock to the user. Using regular alternating current duplex receptacles for direct current applications may degrade the performance and efficiency of the radio system. The recommended solution involves replacing the regular alternating current duplex receptacles with 28 volts direct current compatible receptacles and installing separate wire mold for the direct current circuits. This will ensure compliance with the code and provide a safe and functional electrical system for the radio application. The fact that the system was designed by an electrical professional engineer does not automatically guarantee code compliance. It remains the responsibility of the electrician installing the system to verify compliance and rectify any errors. In this case, the electrician should have identified the mismatch between the receptacle rating and the branch circuit rating, along with the absence of ground fault circuit interrupter protection. The installation of a standard 120 volts alternating current receptacle on a 28 volts direct current circuit is a significant safety hazard and a violation of electrical codes. This configuration poses a risk of electrical shock and equipment damage if the user attempts to plug a 120 volts alternating current appliance into the 28 volts direct current outlet. The use of incorrect receptacles can lead to improper voltage delivery, potentially damaging the connected equipment or creating a fire hazard. To address this issue, the existing 120 volts alternating current receptacles must be replaced with appropriate 28 volts direct current receptacles that are specifically designed for the radio application. These receptacles should be clearly labeled to indicate their voltage and current ratings, preventing accidental use with incompatible devices. Furthermore, it is essential to ensure that the wiring and circuit protection are properly sized for the 28 volts direct current system. Using undersized wiring can lead to voltage drops and overheating, while inadequate circuit protection can increase the risk of electrical fires. The ground fault circuit interrupter protection is crucial for preventing electrical shocks in potentially wet or damp environments. Ground fault circuit interrupters monitor the current flowing through a circuit and quickly interrupt the power supply if a ground fault is detected. This can significantly reduce the risk of electrical shock, especially in areas where users may come into contact with water or other conductive materials. To comply with electrical codes and ensure safety, it is recommended to install ground fault circuit interrupter receptacles or circuit breakers in areas where electrical equipment is used near water sources. When selecting receptacles for a specific application, it is important to consider the voltage, current, and environmental conditions. Using receptacles that are not rated for the intended voltage or current can lead to overheating, equipment damage, or electrical fires. Additionally, receptacles that are not designed for use in wet or damp environments can corrode and fail prematurely, increasing the risk of electrical shock. The use of appropriate wiring methods and materials is essential for ensuring the safety and reliability of electrical systems. Wiring should be sized according to the National Electrical Code requirements based on the anticipated current draw. Overloaded wiring can overheat and cause insulation damage, increasing the risk of electrical fires. Furthermore, the wiring should be protected from physical damage and environmental factors such as moisture and corrosion. The installation of separate wire mold for the alternating current and direct current circuits is crucial for preventing interference and ensuring the integrity of the electrical system. Running alternating current and direct current circuits in the same conduit or wire mold can lead to electromagnetic interference, which can disrupt the operation of sensitive electronic equipment. Additionally, mixing alternating current and direct current circuits can create a safety hazard if a fault occurs in one circuit and affects the other. Proper labeling of electrical equipment and wiring is essential for preventing confusion and ensuring the safety of users and maintenance personnel. All receptacles, switches, and circuit breakers should be clearly labeled with their voltage, current, and function. Wiring should be labeled at both ends to indicate its purpose and destination. Proper labeling can help to prevent accidental use of incompatible equipment and facilitate troubleshooting and maintenance. Regular inspections and maintenance of electrical systems are crucial for identifying and addressing potential hazards before they cause accidents. Inspections should include checking for damaged or worn wiring, loose connections, and corroded receptacles. Maintenance should include tightening connections, replacing damaged components, and testing ground fault circuit interrupters. Implementing a comprehensive electrical safety program can help to prevent electrical accidents and injuries. The program should include training for employees on electrical safety procedures, regular inspections and maintenance of electrical equipment, and the use of appropriate personal protective equipment. By following these safety measures, organizations can create a safer working environment for their employees and reduce the risk of electrical hazards. The National Electrical Code provides comprehensive guidelines for the safe installation and operation of electrical systems. Compliance with the National Electrical Code is essential for ensuring the safety of people and property. The National Electrical Code is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. It is important to stay informed about the latest National Electrical Code requirements and to ensure that electrical systems are installed and maintained in accordance with these standards. The selection of appropriate electrical equipment and materials is crucial for ensuring the safety and reliability of electrical systems. Electrical equipment should be listed or labeled by a recognized testing laboratory, such as Underwriters Laboratories or Canadian Standards Association, to indicate that it has been tested and meets applicable safety standards. Materials should be selected based on their suitability for the intended application and environmental conditions. The use of substandard or counterfeit electrical equipment can pose a significant safety hazard. Such equipment may not meet safety standards and may be more likely to fail, leading to electrical shock, fire, or other hazards. It is important to purchase electrical equipment from reputable suppliers and to inspect it carefully before installation. The proper grounding of electrical systems is essential for preventing electrical shock and minimizing the risk of electrical fires. Grounding provides a path for fault current to flow back to the source, causing the circuit breaker or fuse to trip and to energize the circuit. This can prevent dangerous voltage from appearing on metal enclosures or other conductive surfaces. Grounding systems should be installed in accordance with National Electrical Code requirements. The use of extension cords should be minimized, as they can be a safety hazard if used improperly. Extension cords should be used only for temporary applications and should be sized appropriately for the connected load. Extension cords should not be run under rugs or furniture, as this can damage the insulation and create a fire hazard. The use of surge protectors can help to protect sensitive electronic equipment from damage caused by voltage spikes or surges. Surge protectors divert excess voltage away from the equipment, preventing it from reaching damaging levels. Surge protectors should be installed on all circuits that power sensitive electronic equipment. The importance of seeking qualified electrical professionals when dealing with electrical installations, repairs, or modifications cannot be overstated. Working with electricity can be dangerous, and improper procedures can lead to serious injury, fire, or even death. Qualified electrical professionals have the knowledge, skills, and experience to perform electrical work safely and in accordance with applicable codes and regulations. They can also identify and address potential hazards that may not be apparent to untrained individuals. Always hire a licensed and insured electrical contractor for any electrical work that requires expertise or involves potentially hazardous conditions. Attempting to perform electrical work without proper training and qualifications can be extremely dangerous and is not recommended. There are numerous resources available for learning about electrical safety and best practices. The National Electrical Code, National Fire Protection Association, and Occupational Safety and Health Administration websites provide valuable information on electrical safety standards and regulations. Local electrical training schools and community colleges offer courses on electrical safety and wiring techniques. By taking advantage of these resources, individuals can improve their understanding of electrical safety and reduce the risk of electrical accidents. Remember that electrical safety is a shared responsibility. By following safe practices and being aware of potential hazards, everyone can help to prevent electrical accidents and injuries. If you have any doubts about the safety of an electrical system or device, consult with a qualified electrical professional before taking any action. Your safety and the safety of others depend on it. In summary, the initial scenario presents a multitude of electrical safety and code compliance issues. Addressing these issues requires a comprehensive approach that includes replacing incorrect receptacles, installing ground fault circuit interrupter protection, separating alternating current and direct current circuits, ensuring proper wiring and circuit protection, and implementing a robust electrical safety program. By taking these steps, it is possible to create a safe and functional electrical system that meets the needs of the radio application while protecting users from electrical hazards. Always prioritize safety and seek the assistance of qualified electrical professionals when dealing with electrical systems. Remember, electricity is a powerful force that can be dangerous if not handled properly.